Hello everyone, this is another problem on projectile motion. So for instance, a cannonball was fired from the edge of a 10-meter high cliff at an angle of 30 degrees. The ball reaches the peak after 4.5 seconds. Now assume that the air resistance is neglected. Calculate A, the initial velocity of the cannonball and its components, B, the height of the peak from the ground, C, the total time of flight, D, the velocity of the cannonball as it hits the ground, and lastly, the distance of the landing point from the base of the cliff. To solve this problem, first, let's draw an illustration showing this situation. So this is the cliff. This is 10 meters high. And then we have here a cannonball. So let's say this is the cannonball. So it was fired at an angle of 30 degrees. So note that this is not on scale. So this is 30 degrees. Now this ball reaches this peak here in 4.5 seconds. Now we are asked to look for the initial velocity of the ball here. So this is the initial velocity, and of course its x and y component. So this is the x component of the velocity, this is the y component of the velocity. And so we have v here, and then this is v naught y, so this is v naught, and then this is v naught x. Now we are also asked to look for the height of the peak from the ground. So this is the height, so this is h. So assuming that this ground is a level ground, okay, and we are also asked to look for the total time of flight, so t total, and of course the velocity of the cannonball as it hits the ground. So of course this will eventually hit the ground. So again, it's not to scale. This is the velocity of the ball as it hits the ground. So this is vf. Although in this problem there are times that we will consider this as the vf, there's also a time that we will consider this as vo. So it depends on what we're looking for, but we will go to that later. And of course, lastly, for E, we are asked to look for the distance of the landing point. So this is basically the horizontal distance. So here, this is D, okay? So from this point up to this point. So that's what we're looking for. So again, let's recall some of the formulas that we have to use. For the vertical, okay, we can use these equations. So VF, so to avoid confusion, let's include the component here. So this is VFY, so since we're dealing with a vertical, equals V naught y, or the initial velocity on the y component or the y-axis, plus G, which is the acceleration due to gravity, and then of course time. So this is the first equation. Okay, so next is equation 2. Okay, so equation 2 is delta x. Okay, so for consistency, since it's on the vertical axis, let's just use delta y this time. So it's equal to v naught y, and then times time, plus 1/2 gt square. So for equation 3, we have v fy square is equal to v naught y square plus 2 g delta y. So these are the equations that we can use for the vertical components. So again, it involves g here, or the acceleration due to gravity, since acceleration due to gravity or gravity only acts on the vertical axis. Now for the horizontal, what we're gonna need is this equation. So vx is equal to d divided by t. So this time we can make it dx, or it can be also the same as delta x divided by time. First problem. So the initial velocity of the cannonball and its components. So note that we have these given values. We have time, it's equal to 4.5 seconds, and then we also have g, which is equal to negative 9.8 meters per second square, and also we have vf y. So if you will look at this, so at the top of this, the y component of the velocity is 0, so vf y here is equal to 0. Now given these values, we can solve for vf or v naught y. So since we have t, we have g, and we have vfy, we can use this equation. So that is vfy, it's equal to v naught y plus gt. Isolating v naught y, so that's v naught y, it's equal to vf y, so transpose gt here, so that becomes negative gt. Substitute the values, so again this is 0, so 0 minus rg is negative 9.8 meters per second square times time, which is 4.5 seconds. Okay, so that would be equal to 44.1 meters per second. So note that this is v naught y. Now for us to get the initial velocity, so this is just the v naught y. Okay, so to get the resultant velocity or the initial velocity, note that in solving for v naught y, it's equal to v sine or v naught sine theta, since if we have this, so for instance this is our v naught, it has two components, so this is v naught x, and this is the y component, this is v naught y. Okay, now since if this is our angle theta, v naught x here is the adjacent side of the angle theta, while v naught y is the opposite side of angle theta, while v naught here is our hypotenuse. Now if we will use the adjacent side and the hypotenuse, that is cosine, since adjacent over hypotenuse is cosine, while if we will use the opposite side and the hypotenuse, we will use sine, since sine is equal to opposite over hypotenuse. So that's why here, since we are looking for the vy, we have to use the sine theta. So that's equal to v sine theta or v naught sine theta, but we are looking for v naught, so let's rearrange this equation. So v naught is equal to, so we just cross multiply, so that's v naught y divided by sine theta, and that's equal to, so our v naught y is 44.1 meters per second, and then that's we divide it with the sine of the theta, which is 30 degrees. That's equal to 88.2 meters per second. Now we already have the v naught or the initial velocity, so we can solve for vx or v naught x, or the x component of the initial velocity. So since we use sine here, so we will use cosine to look for the v naught x. So v naught cosine theta, that's equal to, so let's use this, 88.2 meters per second multiplied with the cosine of 30 degrees that's equal to 76.38 meters per second. So we now have this v naught x, and then the v naught, or the initial velocity, and this is the y component of the initial velocity. Letter B, the height of the peak from the ground. Now to solve for that, let's look at the drawing again, or the illustration. Now we have two heights here. So the first height is the height reached by the cannonball with respect to this line, and of course we have given here 10 meters. That's the distance from this point and from the ground. So we only have to look for this portion of the height. So this is, let's call this delta y. So to solve for it, so let's say we have h, or the total height, that's equal to delta y plus 10 meters. Now we have to look for delta y first. We can use any of these two equations. So this equation 2 or equation 1. So it's better if we will try both, right? So first, let's use the second equation. Delta y is equal to v naught y times time plus 1/2 gt squared. Now our v naught y here is equal to, we already calculated this, so that's 44.1 meters per second, and our time is already given, which is 4.5 seconds, and our g is negative 9.8 meters per second. Y is equal to 44.1 meters per second times 4.5 seconds plus 1/2 times negative 9.8 meters per second square times time square, which is 4.5 second square, and that's equal to 99.23 meters. So this is delta y. Now let's try to use equation 3 if we will get the same answer. So delta y is equal to vfy squared minus v naught y squared divided by 2a. So it's equal to, now we know that vfy is 0, so this becomes negative, our initial velocity is 44.1 meters per second, and then we have to square this and then divide by 2 times negative 9.8 meters per second square, and this will be equal to 99.23 meters also, which is the same as this. Okay, so this is just delta y. We still have to look for h. So h is equal to delta y, which is 99.23 meters plus 10 meters, and this is equal to 109.23 meters. So this is now our the height of the peak with respect to the ground. Now our next question is the total time of flight. Now to get the total time of flight, so we have time total, so this is equal to, okay, let's look at this again. So we are given with 4.5 seconds, so this is just a time for the cannonball to go to the peak. Okay, so that's the first time. So time 1 is equal to 4.5 seconds. Our second time, or that we have to look for, is the total time, or the time for the cannonball to fall from this peak going to this point, which is the ground. So this time is t2. Okay, therefore our total time is equal to the time 1, which is the time going up, plus time 2, which is the time for the cannonball to go down. Now, to get time 2, so let's list the given values first, or the values that we were able to solve. Now, so the initial velocity is equal to, so it's kind of tricky since we have to change our perspective. Our initial velocity here should not be the same with the initial velocity we used earlier here, since t2 is the time of falling, so from this peak going down this going to the ground, right? So our initial velocity here becomes 0, since the velocity, or the y component of the velocity at this point is 0. So this should be 0. And we are also given with our height, which is equal to 109.23 meters. And of course, we have g, which is negative 9.8 meters. Now we have to use an equation that has these values. So we can choose from these equations. Okay, but this time we don't have VF, right? So we don't have VF, we don't have here we also don't have VF. So our only choice is to use delta y, okay, or the second equation, delta y is equal to v naught y t plus 1/2 gt squared. So let's use that equation. Delta y is equal to v naught y times time plus 1/2 gt squared. So again, this is t2 t2. Now our v naught here, so again our initial velocity is 0, so this is cancelled. So we're left with delta y. Now instead of this delta y, we're given with h, which is 109.23. So that's 109.23 meters. That's equal to 1/2 times negative 9.8 meters per second square times time 2 square. Now to isolate time, so that's time 2 is equal to square root of, okay, so this is 2, so we have to cross multiply 2, and then it will go here, so times 109.23 meters divided by negative 9.8 meters per second. Now since this is going down, we can say that the displacement is negative. So here h is negative since it's going down. The magnitude is 109.23, but since it's going down, we can put a negative sign here to indicate that it's going down. So it's negative, that's equal to 4.72 seconds. So this is our time 2. Now to calculate for total time, so that's equal to time 1, which is 4.5 seconds plus 4.72 seconds, so that's equal to 9.22 seconds. So this will be our total time. So we're done with letter C. Now the next item is the velocity of the cannonball as it hits the ground. So that's actually the final velocity. To get the final velocity, we can use the first equation or the second equation. Now we already have this v naught y, or the initial velocity, plus we also have the total time, or the time here, and we also have g. So maybe it's better if we can use equation 1. So let's use that. So vf y is equal to v naught y plus gt. Okay, since v naught y is 0, this will become negative 9.8 meters per second square times time, which is, okay, we will use t2 here since t2 is the time of falling from the top or from the peak of the trajectory to the ground. So we can use 4.72 seconds, 4.72 seconds, and that would be equal to 46.26 meters per second. Now, this is just Vy, but we're looking for the velocity of the cannonball. So velocity of the cannonball is equal to the square root of Vfy square plus Vfx square. Since we have this is v, and it has two components. So this is the Fy, so this is Vf, and this y component or this x component is Vx or Vfx. Okay, now to get this resultant vector or resultant velocity, we will just use the Pythagorean theorem, Pythagorean equation. So that's equal to square root of, okay, our 46.26 square plus our Vfx. So we know that velocity in the x component is constant, therefore v naught x is equal to Vfx. And from our previous computations, our initial speed for the x component, or our initial x component of the velocity is 76.38 meters per second. So that's equal to 76.38 meters per second. So here we have 76.38 square. So that's equal to 89.3 meters per second. So this is our Vf. Okay, the final velocity. Last question. So we are asked to get the distance of the landing point from the base of the cliff. So this is what we're looking for, the distance from this point up to this point. So that's actually the x component of displacement, or d. So since we know that in the x-axis velocity is constant, so therefore we can just use this horizontal equation, or the equation for the horizontal components. So Vx is equal to dx over t, or delta x over t. So our initial velocity v naught x is equal to 76.38 meters per second, and our total time is equal to, okay, 9.22 seconds. Okay, so v naught or Vx is equal to, so this is also equal to Vx. Okay, Vx is equal to d over time. Okay, and therefore we have d is equal to Vxt, and Vx is 76.38 meters per second times the total time, which is 9.22 seconds. So that is equal to 704.22 meters. So now this is our dx, and that's our final answer. So that's all for today. Thank you for listening.